We'll now start looking at Chapter 6, which is based on probability. Section 6.1 in our book starts talking about the idea of a chance experiment, and we will mention that, but we really want to start getting into Section 6.2, which discuss the basics of probability, and 6.3, where we'll start getting the properties of probability. We will get a little more information from the end of Chapter 6, and we'll probably make an extra video to start covering some of those harder cases. But the first thing for today, let's get the basic definition for the probability that event E occurs. The whole idea and concept behind probability is all based off the sense of the likelihood, the chance, the likelihood that a certain situation actually occurs. So it's worthwhile going back and reading section 6.1, talking about a chance experiment, seeing exactly what we mean and what the different situations are. There's different terminology that we'll come back to. But again, trying to get the biggest, most important concept, which is the probability that event E occurs. This will be our notation. We use the capital P for probability. And when we're talking about different events, we'll use some different notation. The notation is not the most important aspect here. It has to do with the process. The literal formula that we get for the probability event E occurs is simply the number of outcomes satisfying event E divided by the total number of possible outcomes. Now, our book takes this a little further, talks about the idea of classical probability, talks about the idea of theoretical probability, but it'll always come down to this basic concept. The number of outcomes, the number of people, the number of objects that satisfy whatever it is we are looking at, divided by the total number of people, the total number of objects, the total number of possible outcomes. So let's start off with a really, really simple first example. If we roll a standard 6-sided die, right? Like playing a board game, we have a set of dice, but now we're only looking at one of them. If we roll this standard 6-sided die one time, what is the probability that we roll a 5? So, using the notation that I've been discussing, we write P of 5, the probability of rolling that number 5, and we have to think about it. How many outcomes satisfy rolling that number 5 out of the total number of possible outcomes? Well, if we think of a 6-sided die, there's 6 sides, each side has a number on it. The number of outcomes is the total number of sides, so we have 6 total possible outcomes. The sample space, which was something they mentioned earlier in the book back in 6.1, is the collection of all the possible outcomes. So we're focusing on the number of those outcomes, but if we want to know the actual outcomes, the outcomes are that we roll any of the numbers 1 through 6. 1, 2, 3, 4, 5, or 6. So the probability that we roll a 5, well, one of those outcomes is a 5, so there's one event that satisfies, and there are 6 total outcomes here, so our probability would simply be 1 out of 6. Now, this was still a very basic situation. Using our formula, this really sets us up with the idea that a probability is a fraction in this basic form, and that's exactly what we got here. We'll move along very quickly and realize fractions, decimals, these are the exact same thing. In certain situations, it's easier to use a decimal versus a fraction. And we'll also see how percentages also start sneaking their way in here as well. But let's still stick with this example for just another couple of moments. Let's still roll this standard 6-sided die, but now, what's the probability we roll a number larger than 4? Still the same basic situation. We're still rolling a die, and you'll notice as we keep going forward, there's always two components to our probability formula that we're always looking for. Again, the number of outcomes that satisfy out of the total number of possible outcomes. I always like to start with the bottom. How many total outcomes do we have? Well, we're still rolling that same die, so our number of outcomes, so here, my notation, probability, number greater than 4. We still have 6 possible outcomes. We're still thinking about that same 1 through 6 are the possible numbers that come from rolling the die. But now we want to roll a number larger than 4. While looking at our possible numbers, the numbers 5 and 6 would satisfy event E. The biggest thing that people start getting confused with here, especially, and this is why I chose this as a first example, there's a lot of numbers floating around here, but we have to keep separating in the number of outcomes that satisfy, the number of possible outcomes. So what satisfies a number larger than 4, a 5 or a 6, but the point is that there are 2 outcomes that satisfy out of those 6 possible outcomes. So 2 out of 6, 2 over 6. We like to reduce fractions if we can. That is 1 out of 3. Going back to the previous one, again, especially as we use our calculators, there's no problem getting the decimal and leaving it like that. As we've said in class a bunch, how do you round? Well, you could, go to any of the decimal places, use the following. So if you go to the second decimal, we'd make it 0.17 because this is bigger than 5, so round that up. In this one below, this would be 0.333 repeating. And again, could round appropriately like we were mentioning. Our second video, we'll start giving some higher level examples, but this is just a beginning.